In this video, we're going to talk about dividing radicals. Before we do that, let's talk about the quotient rule for radicals. So let the nth root of a and the nth root of b be real numbers where b does not equal 0 and where n is greater than or equal to 2 and also an integer. Then the nth root of a divided by the nth root of b is equal to the nth root of a divided by b. All right, so let's take a look at a couple of scenarios where this quotient rule would come in handy. Now, notice 6 divides into 24 evenly, and a squared divides evenly into a to the 6th. So this is a really good example of using the quotient rule. Well, let's use that here. Well, 24 divided by 6, that is 4. A to the 6th divided by a squared. Remember, you subtract the exponent, so that's a to the 4th. Now, what we have left is a perfect square. So the square root of 4 is 2. The square root of a to the 4th is a squared. All right, let's take a look at another example. So both the numerator and the denominator have a 4th root. And again, notice 3 divides into 48 evenly. A divides into a to the 9th. And b to the negative 3rd and b we can also simplify. So again, another good example of using the quotient rule. So I'll write it as one radical. So 48 divided by 3, that is 16. A to the 9th divided by a is a to the 8th. And b divided by b to the negative 3rd is b to the 4th. This is a perfect 4th root. The 4th root of 16 is 2. The 4th root of a to the 8th is a squared. And the 4th root of b to the 4th is b. All right, so let's take a look at one other example. Now, this time it is one big radical. But you notice the bottom? I know what the cube root of 64 is, and I know what the cube root of 125 is, but we know 64 does not divide into 125. So I'm going to use a quotient rule, but I'm going to write them as two separate radicals. So I've written below what the cube root of 125a cubed and b to the 4th and the cube root of 64 is going to be. Okay? So I can rewrite. And we're done here. So the next part in this lesson, so now we will examine quotients in which the radicand in the denominator doesn't divide evenly in the radicand of the numerator. We want to rewrite the expression that doesn't contain a radical in the denominator. The process of removing radicals from the denominator is called rationalizing the denominator. All right, so first off, we're going to rationalize the denominator when the denominator is a monomial. Now, if you recall, we talked about this earlier, that the square root of a times the square root of a is equal to a. No radical. All right, so now let's use this idea to help us simplify by rationalizing the denominator. Now, in this example, we know I cannot divide the square root of 10 into 5. So we know we can't use the quotient rule like we did in the previous examples. But we can multiply the top and the bottom by the square root of 10. And we can do this because we're multiplying by 1. And when you multiply by 1, nothing changes. So the top, 5 times the square root of 10, is exactly 5 times the square root of 10. Square root of 10 times the square root of 10 is 10. Now, I can simplify the 5 on the top with the 10 on the bottom. That simplifies to 1/2. So I can rewrite this as the square root of 10 over 2. I cannot simplify further because the 10 is in the radical and 2 is not in a radical. All right, let's take a look at another example. Now I have a radical in both the numerator and the denominator, but 7x does not divide into the square root of 3. So again, I cannot use the quotient rule for this, but I can rationalize the denominator. So I'm going to multiply the top and the bottom by the square root of 7x. So the square root of 3 times the square root of 7x is the square root of 21x. On the bottom, I have the 2. Well, the square root of 7x times the square root of 7x is 7x. And then I'll rewrite the numerator. And on the bottom, 2 times 7x is 14x. Again, I cannot simplify because I have a radical in the numerator and I do not have a radical in the denominator. So I cannot simplify any further here. All right, one other example I want to take a look at then. There's two different ways I can do this problem. Option 1, I can multiply right now by the square root of 12. And on the top, that gives me 6 times the square root of 12. Square root of 12 times the square root of 12 is 12. 6 over 12 simplifies to 1/2. So I can rewrite it as the square root of 12 over 2. But now notice the square root of 12, there are perfect roots I can pull out. So notice the square root of 12 is the same thing as 2 times the square root of 3. So I'll substitute that in. Now notice the 2 on the top and the 2 on the bottom divide out. They're both outside the radical. So that simplifies to the square root of 3. Now the other option is I can simplify the square root of 12 right now. Well, again, we know that's the same thing as 2 times the square root of 3. 6 divided by 2, that is 3. Notice I still have the radical in the denominator, so I need to multiply the top and the bottom by the square root of 3. On the top, I have 3 times the square root of 3. On the bottom, the square root of 3 times the square root of 3 is 3. And this 3 and this 3, they divide out. And that also gives me the square root of 3. Whichever method you find easier, that's what you can use in this particular case.